Alright guys, this is going to be the last project that we're going to be working on, the ARC69 minter modifier. There's going to be a lot of code, so if you'd like, you can follow along on the website where you have code snippets. If you're watching on YouTube, it might be a little bit easier. But we're just going to start off as we typically do with a .env file and also generate account. I'm just going to quickly generate an account. Private key, address is equal to generate account. And we're going to print the private key and address. We're going to take this private key, go in our .env, create a private key variable, post the key in there. And we won't need our address in here, but I'll just paste it in just in case. And we're going to go to bank.testnet.algoLearn.network, paste in the address so we can have it funded. We might have to fund 1 or 2 times throughout the video because we're going to be minting a lot of NFTs and we have that MBR. 0.1 algo per NFT plus the transaction fee we need to fund to the contract when it mints. And the next thing we're going to do is drag and drop 3 Pokemon images. So I have Bulbasaur, Charmander, and over here I also have a Squirtle. And what we're going to do, and maybe I should put these in a folder, Poke images. So I created a folder. I'm going to click each one of these and drag them in here. If you want to multi-select images, hold Control, and you can select multiple at a time. So we have that in Poke images. And now we're going to create a new file called gets image IPFS hash with underscores as spaces. And we're going to use a Pinata client, but you can use any IPFS storage solution you'd like. So over here, I'll just close these tabs. Over here, I'm in my Pinata account, so you can go to pinata.cloud and log in, and you'll see this screen here, this home screen, and click on API keys and generate a new key and just give it admin rights. So all of this is allowed, and I'll just call it my key. Generate, and now we have these 3, we have the key, secret, and JWT, or secret access token. And in our .env, we're going to create a value for each one of these. So API underscore key is equal to, just paste that in. First one, API secret, same thing. And then JWT, super long one. And once that's done, we're going to go to our get image IPFS hash, import from .env, import load.env, load.env, and we're going to import OS as well. And we're going to define our key, secret, and JWT in here. So our key, or API underscore key, is equal to os.getEnv API underscore key. Our secret key or we'll name it API secret to keep it consistent, is os.getEnv API secret, and our JWT is equal to os.getEnv JWT. And the Pokemon images, we're going to define the file names for all 3 of these. And we need to take note that since it's in a folder, this is going to be the subdirectory, the parent folder. So we're going to create a Pinata client first, and then we'll get into that. So Pinata API key is equal to API key, and our secret key is equal to API secret, and our access token is equal to JWT. Now we have a connection to Pinata for uploading. And here I'm going to state file names is equal to a list. And this is so we can iteratively upload each image to IPFS, and you'll see me do this here. So the directory is going to be, I believe, Poke images / vulva.png for the first one, and we can just copy and paste this twice and rename the PNG for the second two. So Charmander, and then we have Squirtle. And we can try iterating through this now for file or for name and file names. Print name. And it's going to print each name. So what we're going to do is upload each one of these files. So we're going to state here the response from pinning this directory or this image file it's going to have a dictionary return, and we're going to go into the data key. And in the data key, there's going to be another key called IPFS hash. And this is similar to the ARC69 video that we recorded recently. https://gateway.pinata.cloud/IPFS/ plus the image IPFS hash. And we can print the hash and print the viewable hash in case you want to take a look at that. And we'll even print these side by side because we're going to use these image IPFS hashes to store into the minturn modifier contract. Let's run this. Looks fine. Perfect. So we can control click these links and confirm that our images are hosted. So there's Bulbasaur. Close this. Here's our Charmander, the second one. And lastly, we have our Squirtle. And for now, we're just going to save these. So I'm just going to paste them in this code here and comment it out. Okay. And I'm just going to make this a tiny bit bigger here. And we can push this off to the left a little. And now we can start working on our contract. So I'm going to create a new file. And I'm going to call it ARC69 NFT modifier.py. So the first thing we want to accomplish is just minting an ARC69 through the contract. And we're going to do that now. And we're going to import quite a few things to start, so we don't have to keep scrolling back up to import. So from AlgoPy, import arc4 contract. We're going to need inner transaction to submit the ASIC config, global state, uint64, group transaction, bytes, subroutine, and string. And then from algopy.arc4, import ABI method. And we're going to import uint64s and strings from the algopy.arc4 library uniquely. So we're going to state here from algopy.arc4 import uint64 as arc4 uint64, and from algopy.arc4 import string as arc4 string. Then we're going to define our contract class here. So class arc69 NFT modifier. We'll name it the same as the file name. Arc4 contract, pass that in. Def init, pass in self, return none. And we're going to have a counter for each Pokemon created. And you'll see how we use this later. But this is going to be, for example, in a Pokedex, for each Pokemon that's created, they have a unique number. And this is going to be our Pokemon unit counter. So each time we mint a Pokemon, they're going to have a unique number assigned to it. And then we can write our first ABI method. So we add that decorator for ABI method. And we're going to call it mint arc69. And for now, we're just going to pass in self and return none. And we'll pass and go over the application client. So for the application client, we'll create a new file here, and we'll call it mints_Pokemon.py. So we're going to need details passed to the contract about the Pokemon that we want to mint. So we have a, for example, the Pokemon name is going to be something that we want to pass in. So we're going to do this 3 times. And we have Charmander and Squirtle as well. And then we might also want to pass in the Pokemon type. So Bulbasaur is a grass Pokemon. Charmander is fire. And Squirtle is water. And we're going to click each one of these. So hold Alt, the Alt key, and click each of these positions here right after the E. And we're going to put an underscore and just put 1. And then we'll go down here and do 1, 2, 3 like so. Another thing we might want is a description. So we'll keep it simple. So Pokemon description _1 is equal to a grass Pokemon. Pokemon description _2 is equal to a fire Pokemon. And Pokemon _description 3 is equal to a water Pokemon. We'll just keep it simple. And now we need a IPFS hash for each of these Pokemon, which we have down here, and also in our, we commented these out here, so we can grab them from here. I'm just going to grab them from the terminal, since I still have it there, to make things a bit faster. So Pokemon IPFS hash 1 is equal to, I'll just copy this and rename these. And I'm going to copy the hashes for each one. And that should be about it for information about the Pokemon we'll need to pass in. So we're going to need a couple things here imported from AlgoSDK.v2 client. Import algot_client. From AlgoKit _utils, import application client. From AlgoSDK, atomic transaction composer, import atomic transaction composer. Oh. We're going to need the account transaction signer and the transaction with signer. We'll also need a payment transaction class from the transaction library. This is going to be so we can pay the contract with the MBR for creating the asset. We're going to need to get our address from a private key, even though we did technically save it here. I like to use the address from private key function. And we're going to need pathlib to define the app spec for the application, the JSON that was generated. Well, we will generate it. And we also need ABI type and import OS, lastly. So we'll push this down a bit and start off by defining our token. And we also need to get .env, because my environment does not require me to load the env, but sometimes you guys will need to do this if your Visual Studio doesn't automatically recognize this .env. So os.getEnv, algod token, and node server is equal to os.getEnv, algod server. And the algod token is always empty. The algod server we get from Nodely. So quick start, nodely.io, hit quick start. Over here under testnet, grab the testnet algod API. Paste that in here. Going back to our mint Pokemon. We're also going to pull in our private key, os.getEnv, private key. And now we can start constructing the variables for the application client. So let's define our application client. So application client is equal to an instance of an application client. Algod client is equal to, and we'll create an algod client here. Pass in our node token and node server. And where is our, from algostk.v2client.algod, import algod client. So we're going to pass that in. Next up, we need an app spec. App spec is equal to path file dot parents / and then it hasn't been created yet, our JSON, but it's going to be the name of our class here, arc69 NFT modifier dot arc32 dot JSON. And let's add the period / here. So this is our app spec. Next up, we need an app ID, which we'll just set this equal to app ID. And we'll get this from our env, which we don't have just yet, but we'll just pass this in here for when we generate the contract. And next up, we need a signer. And signer is equal to account transaction signer. Pass in our private key. We're going to need a sender, which is just our address. Address from private key, private key. And we need suggested params lastly. And this we can get from our algot client. And there's our application client. So for each NFT that we mint, we need to create a payment transaction. And actually, it might be better to start working on the contract so you can have a better idea of why we're creating some of these arguments. So we're going to stop here and move on to the contract. So coming back to the contract, we now have an idea of what kind of arguments we'll be passing in. So we're going to pass in the name, type, description, and IPFS hash. And then we're also going to add an argument for a payment transaction. So Pokemon underscore name is equal to an arc4 string, and we need to use a colon. Pokemon type, it's also an arc4 string. Pokemon description, arc4 string. And the Pokemon IPFS hash, arc4 string. And then the payment transaction, or we'll call this MBR fee, minimum balance requirement fee, is going to be an instance of a payment transaction in the group. And we'll return an arc4 string as well. Remove this pass statement. And we'll state here, return arc4 string, minted a Pokemon. The first thing we want to assert is that the MBR fee amounts, the payment they're sending to the contract, is greater than 100,000, which is the bare minimum for, well, it's a fixed amount actually at this time, 0.1 algo per NFT that the contract has created and opted into. And then we also want them greater than or equal to pass in enough for the minimum transaction fee at this moment. Once that's done, we can start our asset creation. And we're not going to pass in config asset because we haven't created the NFT yet. But we are going to define the total. We're just going to mint 1. The manager, we're going to set as the current application address. The asset name is going to be the Pokemon name we just passed in, but it's native type, which is a string. The unit name, we're going to state for now as just PK number. So I'm going to show you how we actually keep track of this Pokemon's identifying number. So Pokemon number 1, Pokemon number 2, etc. Decimals will be 0, so this NFT can't be fractionalized. And the URL, we're going to use this format here for the IPFS gateway. So it's going to be this pasted in plus the image IPFS hash for the Pokemon that we're passing in its native format. And everything else will be in the note field, which we're going to set to a tuple so that we can kind of have this organized a little bit, because it's going to be a very long string and I don't want it flying off to the right here. So the format, and I even have an example over here. The format for metadata is a JSON dictionary. Let's go here. It looks like this. So we're going to try to mimic this format in the contract. So it's going to be a string. Arc69 standards use a note field to define metadata and properties. So we're going to create a string here. Start off with a curly bracket. And now a double quote. Standard. Arc69. MIME type. Image / PNG. / properties. And we're going to have another dictionary in here. And we're going to close this string here. And since this is a tuple, we can just press enter and continue typing. It's going to treat it as one long string. It's just easier for us to look at in this way, which you'll see. So we're going to create another string here. Type. And we're going to pass in. So we're adding a space here. And we're going to pass in here the Pokemon type in its native format. And close this as a string. Description. Close the string. Pokemon description in its native format as a string. Close that. And so if you understand what's going on here, so we're defining type as a string here. And then this is the value to this key type. It's another string, so we're manually putting in these quotation marks and passing in a string here. So we put these apostrophes in so that we can kind of continue this string format. And it seems confusing, but just try to keep up here. It's going to be okay. And next up, we're going to define level. And we can manually just insert 1. So this is going to be the default level. And we need a comma because we're going to continue. And then experience. Default 0. And then we're going to close the string here before this apostrophe. And that's done. Oh, we also need a fee. So comma here, fee. And we can submit this transaction. So now that we have an idea of what this looks like, the structure of the method, we can go back to our application client and try to compose a call for this method. So we're going to pass in the name, type, description, hash for the Pokemon, and then also a payment transaction that is greater than or equal to 100,000 microalgo for creating the asset and opting in, as well as the minimum transaction fee for actually submitting the transaction. So what I like to do is kind of copy this and bring it back to my application client. So I have the variable names, and I'll just push this up, go down here. Three single apostrophes. I can just paste this in here and start writing my compose call. So app client, or application client, as we defined here, dot compose call. And the first thing we need to pass in is the atomic transaction composer. So I'll quickly create one here. ATC is equal to atomic transaction composer. So we can start building transactions in here. So pass in ATC, call ABI method, and the name of the method is mint underscore arc69. So this needs to be a string. The Pokemon name argument, we can set to the first Pokemon name we have. I'm just gonna make this a bit bigger here. It's too hard to see for you guys, I'm sure. I'll keep it at this size. So the Pokemon name, Pokemon type, and we'll use Pokemon type 1. Pokemon description, and we'll use Pokemon description 1. And we can also format this. So I'm just going to press enter behind ATC, and then enter at each variable right before them, the parameter actually. And this way everything doesn't fly off the screen. So after description, we need the IPFS hash. So Pokemon IPFS hash is equal to. We'll use this one here. Lastly, we need a transaction of payment type. So MBR fee equals. And remember, these need to match exactly as you declare them in your function, in your method. So let's compile a payment transaction. We don't need this anymore. I'll do it right here. So MBR fee payment transaction is equal to payment transaction. Sender is our address. SP is equal to params. Receiver, it should be the application that we're interacting with. So we should probably go back here and assert that. So the receiver of this payment transaction, assert that it is the current application address. And we can access the app address as an attribute of the application client. And lastly, we need the amounts. So we're going to state the amount as 102,000 microalgo, which is atypical from the standard 101,000. But when I was testing, for some reason, 101,000 didn't work. So I'm assuming maybe it's a bit busier today on testnet, who knows. So this is good. And now we're going to wrap the payment with a transaction with signer class. Pass in the MBR fee payment transaction and our signer. And now this wrapped payment transaction goes under the MBR fee parameter. And then we end this with executing, so ATC dot execute, and pass in our client, algot client, and we'll wait for 2 rounds. And then results, Let's get transaction IDs and results. So transaction IDs is equal to, all right, set results here. Results equals atc.execute. Transaction IDs is equal to, we'll use list comprehension. So it'll be results.abi results, or actually results.transaction IDs I for I in range length results should be fine. And ABI results is equal to results dots ABI results I dots return value for I in range length results dot ABI results. And I'm not sure if this will work directly in the atomic transaction response. I feel like it should. I'm gonna actually just try it. No, because you could have multiple results. Well, let's leave it like this. Maybe it'll. Let's just change it. Let's not try it. Let's do it like this. And let's print our transaction IDs, print our ABI results. And now we need to actually launch our contract and compile it beforehand. So we're going to bring up our terminal here. Make sure you Control S over your contract while you're in the file. Or you can hit File, Save, or Save All. And you're going to type algokit compile pi. And if you don't have algokit or any of this here, there's an installation video at the beginning. Algokit compile pi arc69 NFT modifier.py. And let's see if we have any errors actually. And we gotta update algokit. But this is fine for now, compiled successfully. And now for our launch contract, we always use the same template. I'm gonna grab mine over here on the left, or my right. And I'm gonna create launch smart contract, .py, and just paste this in here. And arc69 NFT modifier dot approval dot teal. Oh, this is new. Puya.map. So arc69 NFT modifier. What is going on? So I have two Puya maps. Sorry, this is the first time I'm seeing this. So arc69 NFT modifier dot approval dot teal and arc69 NFT modifier dot clear dot teal. Make sure you change these approval and clear teal file names in your launch smart contract template according to whatever you named your contract right here. This is what the file name will be. And then for global states, we just need one integer. We don't need any bytes, and this is global. So back to our launch contract. So these two can be 0 for local state. And then we don't need any byte slices, so this can be 0. And this should all be good. And then it funds with 0.1 AlgoLearn at the end. But this is just so that it can be an active AlgoLearn account. That has nothing to do with the opt-in fee for the NFT. And we have our transaction ID. We're going to take this app ID, place it in our .env under app ID. And then we can give this mint underscore Pokemon.py a try and see how this goes. And we'll even should we do this now? No, we'll start simple. Just this one. I was gonna create the other two for these other two Pokemon, but let's just make sure it works first. So run without debugging. And the app ID is a string when we read it from our .env, so we need to convert it to an integer. You can see here, expected an integer for app ID, but got, it even says it's a list, but then class string. And this is going to be, just for your information, in line 56. The first time it tries to access something about the application, which is the app address. Let's try that again. Should be good. And looks like it's executing. We're waiting 2 rounds. Perfect. And we have 2 transaction IDs. The first is the compose call, I'm assuming. And then the second is the payment transaction. Actually, that's reversed. So the payment transaction is first, and the compose call is second. Whenever you pass a transaction as an argument into a compose call, it executes before the actual compose call or application call. So this right here is in the first position here, the 0th index. Now let's take this to, we can go to AlgoKit, but to be honest with you, for looking at NFTs, Pair Explorer might be better. So I'm going to paste in this transaction ID. Make sure you're on testnet for Para. Paste this in here. And let's look at the group. And I guess the easiest way would be to click the app ID that we're interacting with, or even the address that we're sending the algo to. Either one works. If you click the app ID, actually, you'll have to go and click the address anyways. So maybe address would be better. And then you'll see that we have NFTs in this account. And this is the Bulbasaur that we just minted. And you'll see the metadata here is correctly generated. And we have our PK number, which we're going to go over fixing now. We're going to have a global counter for each new Pokemon we add to our contract. So it'll be PK number 1, and then 2, 3, so on and so forth. Decimal 0, everything looks good. And then the metadata you can see here is formatted perfectly, even though we kind of formatted it in a bit of a strange way here, but it works just fine. So I guess while we're here, really quickly, we'll just duplicate this for all 3 Pokemon. So what I'll do is I'll copy and paste the MBR fee payment. And these need to be slightly different. So what I'll do is give them notes. So notes equals number 1, note equals number 2, note equals number 3. And we'll call this MBR payment. Actually, no, we only need to alter the wrapped payment. So we'll call this wrap payment 3, wrap payment 2, and actually 1. This is wrap payment 2. And we'll even call these 1 as well. Let's click in here. Okay, let's put these together so it looks a little easier. And rename these. Okay. A little space between them, that should help. And over here, we're going to duplicate this as well. This will be wrap payment 1, wrap payment 2, wrap payment 3. And we'll launch a new contract. And let's make sure our guy's funded here. And then for the compose calls that we just duplicated, we will need to replace these. So highlight over the 1, hold Control, and hit D. Just 3 times, and change this to 2. Same thing on the third compose call. Highlight the 1, and it's going to be Control D. 1, 2, whoop, 1, 2, 3, and type number 3. Did we change the app ID? Is the question. We did not. So remember to go to your .env and change the app ID. And then the only reason I'm doing this is because I want to confirm that these are all being minted correctly. But that should be given, but let's just be safe. So receiver, NFTs, and Squirtle looks good. Same thing with Charmander, looks good. And Bulbasaur, perfect. And now what we're trying to do is work on having this be incremented per Pokemon. So we're going to use something that's open sourced, and I have it here on the side, because it surely is not something I would ever write, at least not on my own. But it's something that was open sourced, I believe, by the DevRel team, and it's called I to A. And what I to A does is it takes an integer, say an integer like the number 1, and it converts it to B1. So the ACII character 1. So 1 becomes a string because Pyteal, or excuse me, Puya does not support integer to string translation directly. I don't think many, if any, smart contract languages or compilers support that. But what we have here is a little algorithmic workaround to make this happen. And so we're going to take this I to A to convert the counter, the unit counter, into a string. So for every Pokemon we mint, the first thing we're going to do is increment the unit counter by 1. And then we're going to take this value here. We'll create a variable, unit name, integer, as arg4 string is equal to string dot from bytes self dot I to A, this function here, and then we pass in the integer self dot Pokemon unit counter dot value. So it will take the number 1, for example, after the first iteration. So first Pokemon minted will be 1. Passes this to I to A. I to A says, yep, it's going to be byte 1. So this is going to bring back B1. That B1 gets converted to a string from bytes, which basically just takes B1 and converts it to just 1, like so. And now we're going to take this here, the unit name integer as arg4 string, and we're going to place it right here. So pk number plus unit name int as arg4 string. And I don't believe this needs to be native. I think this is fine. And it's actually because we're using the regular string. and it does not store an array length prefix. So with arg4 strings, if you have a string that's 10 characters long, it'll give you the number 10 followed by the actual string in bytes. For the regular string, not the arg4 string, there is no length prefix, which we don't return here. So it doesn't return a string with a length prefix, it just returns the byte character for 1 in this example. And the byte character for 1 just needs to be converted from bytes to a string. There is no length prefix. So this is good. The counter is not established until you give it a value. So when I state here add 1 to the counter does not technically exist yet, so I need to instantiate it with 0. So we'll compile that again and launch that again. Change the app ID in our .env and mint Pokemon again. And we should be good here. Waiting 2 rounds, perfect. Search for this transaction ID. Let's refresh. And what is going on? Why would this have 6 NFTs already? Okay, there we go. Para was messing with me. So NFTs, and we can look at Squirtle, for example, and see PK number 3, Charmander, PK number 2, and Bulbasaur, which was the first one we minted, PK number 1. And we can see the order in which we minted them in our mint Pokemon. So Pokemon number 1 is Bulbasaur, then Charmander, then Squirtle. Bulbasaur was the first, so 0 became 1 in the counter. And then it added that counter as a string right here. So now what we want to do is separate this process of minting a Pokemon into 3 pieces. So we want the user to not pass in their own Pokemon information. We want to, ourselves as the creator, register information about different Pokemon into the contract. Then we want some sort of randomness. So one of the 3 Pokemon we're going to register to the contract, the user will have one of those chosen for them at random. And then once that's chosen, whatever Pokemon they're designated, they can then claim that Pokemon. So what we need to do is this portion here where we pass in information about the Pokemon needs to be separated. So I'm going to delete this for now. And we're going to only keep the I to A here. And we're going to create a class up here for a struct that we need to import from algopy.arg4. And this is going to be called available Pokemon. And we're going to have the same information. So the name will be an arg4 string, the Pokemon type, arg4 string, Pokemon description, arg4 string, and the image or Pokemon IPFS hash is an arg4 string. So we're going to pass in this information about a Pokemon that will exist in the contract and write this to a box. And those boxes will have this counter as the key name. And when they generate a Pokemon for themselves, once we've registered this information to the contract and created the boxes, a random one will be chosen. So it'll either be box number 1 or box number 2 or box number 3. And you'll see how we do this shortly. So to start, we're going to create, and this will be an ABI method, create Pokemon, or better yet, register Pokemon data, new Pokemon data. And we're going to pass in this information here. We'll just highlight this and tab over. And we're going to need commas here. And we need to fund the contract with the MBR for creating these boxes. So for every byte in the key and value of the box, we require 400 microalgo, and then generating a box alone and creating a new box costs 2,500 microalgo. So we're going to calculate that in our Mint Pokemon script over here. But for now, we're going to import boxref from AlgoPy so that we can get started with creating this box. So the boxref is going to have a key, which is the Pokemon unit counter as bytes. And this means that we're going to need to use an arc4 uint64 instead of a uint64, so we can convert it to bytes. And we'll start off at 1. So we confirm the box exists and try to fetch the value using boxref.maybe. And we're going to assert that this does not exist, but technically it's impossible for someone to, for us to query for a box that already exists, because we only increment the global counter through this function. So once this is done, we'll increment the Pokemon unit counter. So the new Pokemon info will be an instance of this new class we created for available Pokemon, where the Pokemon name is the Pokemon name that we pass in here. Pokemon type is the Pokemon type we pass in. The Pokemon description is the Pokemon description we pass in. And the Pokemon IPFS hash is equal to the Pokemon IPFS hash that we pass in. And we're going to create a box. When we create a box, we need to indicate its size. And the size of the box will be the size of the new Pokemon info bytes length. So however long this information is, that's how big we want our box to be. And then we're going to put the new Pokemon info bytes into this box. And at the end here, we can return an arc4 string. We can return a tuple of 2 arc4 strings. And this will be arc4 string, Pokemon registered to contract, and then the Pokemon name. As the second string. And we can even concatenate this if we want, actually. So we can state here, not entirely sure if we can add these together like this, as I've never tried it, but let's see. Oh, Pokemon name is already a string, so we can just try that instead. Perfect. And since we now have new Pokemon data registered, we can create a function or a method to determine the user Pokemon. And they'll need to provide a payment transaction. And we'll return none for now. So the fee that we're going to need for this box, it's going to be the address plus the 8 bytes for the unit that's selected for them, which is going to be a uint64. So we'll do the math on that later, but we are going to want to assert that the payment transaction amount is a specific amount, and assert that the payment transaction receiver is the application address. And we'll do this up here as well for register new Pokemon data. So we're going to find a way to generate some sort of randomness, a random number. And you can do this a number of ways. You can use time, the current round. You can use the transaction ID, convert it to an integer. You can use modulo. You can use a bunch of stuff. And we're going to use just, I guess, all of those. So what we can do is state randomizer is arc4 uint64. So we're trying to generate a number here. And we will do, let's do the global latest timestamp plus the current round. And for transaction ID, we only need 8 bytes. So we will get we can use arc uint64 from transaction, and we're going to need to import this txn up here. So txn.transaction tax ID, and we'll get bytes from position 0 to 8. And this will need to be arc4 uint64 from bytes. And we'll also get the last 8 bytes. So this basically means go to the 8th to last byte, and then get everything to the right of that, including the current index. So this is how you get the last 8 bytes of the transaction ID. So we're converting these into uint64s, which are 8 bytes. So it's just converting it to a number in both of these situations. And we can also do, this is sufficient, I think. So this is the random number that we're going to get. And if we want, we can even hash this. So hash randomizer is equal to, we're going to need op to hash. So up here we import op. So op dot SHA-256 and get the bytes format of this randomizer. And then let's say that get the selected Pokemon or Pokemon selection is equal to a number from bytes of this hash randomizer, position 0 to 8, so we're getting the first 8 bytes, dot native modulo the Pokemon unit counter value dot native +1. Wrap this over here. Yeah, this looks good. So let's say this number is 30, and we modulo by how many Pokemon exist right now. So let's say 30 modulo 2. So 2 goes into 30 an even number of times. So 30 divided by 2 is 15. So that's going to result in 0. Whenever you do a modulo operation, it basically asks if you divided this larger number by this smaller number, what is going to be the remainder? So like 15 divided by 4. So you get 4, 8, 12, and you can't do another multiple without going over 15. So 15 minus 12, the remainder is 3. So that would produce 3. So in this situation, let's use the 15 and 3 example. So 15 modulo 4, you would get 3. And then 3 plus 1 will give you 4. And the reason we do this plus 1 is because imagine we got the number 16 and we did modulo 4. So 4 goes into 16 evenly. So 16 modulo 4 is 0 because 4, 8, 12, 16, 16 minus 16 is 0. So we won't have a 0 Pokemon counter because we start at 1. So we add 1 at the end of this Pokemon selection. And now we can create a user's claim box, which just holds on to the Pokemon selection until they claim the Pokemon. So this user, we're going to use their address as bytes for the key. We get the values. This should not exist. It's possible that they try to determine a user Pokemon twice, but we should assert that they don't have a box or a Pokemon waiting to be claimed already. So what we'll do here is assert that it doesn't exist. Otherwise, they have to claim the Pokemon they just generated. And we're going to create their box size of 8 because Pokemon selection is going to be a UN64. And I don't trust that this +1 will execute correctly. So I'm going to wrap this in another arc4 UN64. And then we can place into the user's claim box using put the Pokemon selection .bytes because the box value must be in bytes format. And now we want them to be able to claim this Pokemon. Or better yet, we're going to mint it first. And I'll explain why. We're going to use opt-in. And we don't need to pass in any arguments here. So the reason why we have minting the Pokemon and dispensing the Pokemon separately is because it's impossible to mint a Pokemon and send it to the user at the same time without the user being opted in. And there's no way for the user to opt in without knowing the asset ID for the Pokemon that we're creating. So it's kind of like chicken before the egg kind of thing. Until we know the asset ID, we can't ask the user to opt in so that we can send the asset, which is why we keep these separately. So what we'll do here is get the claim box that we just registered here when we determined the user Pokemon. And the claim box is going to be a box ref where the key is the sender's address in bytes format. And the claim box value and whether or not it exists is going to be equal to user's claim box dot maybe. We assert that it exists. And then the Pokemon selection is going to be arc4 un64 dot from bytes, so a number from bytes format, which is the claim box value. And this will be either 1, 2, or 3 for the 3 Pokemon that we're registering to the contract here in this top function. So once we have the selection value, this number that's either 1, 2, or 3, we can then get the available Pokemon info with this information. Because the available Pokemon info, the key to this box is just the number, so 1, 2, or 3. So here we can state that the available Pokemon info is an instance of available Pokemon from bytes, and we're going to get the bytes from that box. So the Pokemon info bytes is equal to a box ref where the key is the Pokemon selection as bytes. And the Pokemon info value and whether or not it exists is equal to Pokemon info bytes, maybe. Assert that it exists. If there's no registered information for this number, we don't want to proceed. And then we can pass in these bytes for the Pokemon info here. And now we have the information about the registered Pokemon this user has just had selected for them. And we can start preparing our inner transaction for creating the asset as we did previously. So the first thing that we want to add is a unique number for this Pokemon. Aside from the kind of Pokedex number, so like Pikachu's number 1, Charmander's number 2, we want to have a unique identifier for the specific Pikachu or Charmander. So we can have Pikachu number 1, unique ID is 7, right? And now we tie this Pokemon, even though there might be several of them, we give it a unique ID to tie it to a user. And the reason we do this is because we can have several Pokemon that came out of this contract, but there's no way to distinguish differences between them on chain about the metadata without actually using and storing information into the contract for that user. So what I mean by that is in Arc69s, the way that we adjust is through the note field when we submit an asset configuration transaction. There's no way for me to, in this contract, say, go to the previous asset configuration transaction and tell me what the note field was so that I know the most recent metadata about this Pokemon. Since that's impossible, we register changes to the contract directly. So we'll have Pikachu number 1 with unique ID of 7, and it'll have information about the last metadata in a box in the contract for that user. And this will become clearer as we continue working through this, but essentially, for every single Pokemon that's created, there's a box for that specific Pokemon. So I can have a Pikachu that is level 7 with 10 experience, and a Pikachu that's level 3 with 2 experience, and I'm able to fetch that most recent information about that Pokemon based on the user and their box in the contract. So we're going to go up here, and for a unique identifier for each Pokemon, we're going to create another counter called Pokemon created. Global state uint64. Now we can go back here, and the first thing that we want to get is the identifier for this Pokemon. Not the unique one, just 1, 2, or 3 out of the 3 possible Pokemon. So the unit name, integer, as string, is going to be string from bytes, and we're going to use this I2A function again, self.I2A, and pass in this Pokemon selection value. And then we want to get the unique identifier for this exact Pokemon. So the unique ID as a string is going to be string.fromBytes, and self.I2A, since it's a uint64, we can directly pass in the self.PokemonCreated.value. And here we can start our asset configuration. So Pokemon creation transaction is equal to innerTransaction.assetConfig, and total will be 1. The manager will be the global.currentApplicationAddress. The asset name is going to be available Pokemon info, which is this instance here, dots, and then we have the Pokemon name trait here. And we're going to need this native. And then the unit name is going to be PK number plus unit name int as string. Decimals, and we need this in its native form as well. Decimals is going to be 0, so it can't be fractionalized. And the URL is going to be the https://gateway.pinata.cloud/IPFS/ plus available Pokemon info .Pokemon IPFS hash .native. In ARC69s, we point to the image and URL field. And then we have the notes, which we're going to format the same way, so a tuple. And we'll start off at the top. So the first thing is the curly bracket and the standard, which is ARC69. Then the MIME type. So I'm using a PNG. And then we can start defining our properties here. Then the Pokemon type. And we'll add a space here, so we can start the next value here, and it's going to be available Pokemon info dots Pokemon type dot native, and then close the quotation mark here. Create a comma to start the next one. Description, same thing here. And we need to add colon, and a space here, and the new string. Available Pokemon info dots Pokemon description dot native. Close the string. The level, we're going to default to 1. The experience, we're going to default to 0. And then we're also going to add the unit name and the UID. So we'll call this Pokemon number. And this needs to be in here. And we'll get this from the unit name int as string. Then the unique identifier is going to be the UID as string. And then we can close this, and we're done here. And we can submit this. And we're going to store all the information about this mint into a box for this user specifically. So a new struct, class user Pokemon info, and we're going to store the UID, which is an arc4 uint64, and the owner, which is an address type, which we'll pull in from arc4 library, the asset ID, arc4 uint64, the Pokemon ID, arc4 uint64, level, experience, we'll call it XP, both arc4 uint64s. And this contract is going to have a training method for the Pokemon where they can gain experience and level up. So we're going to declare training here, and this is going to be a bool, which we also get from the arc4 library. And then we'll need training start time to keep track of, arc4 uint64. And lastly, the last notes for this Pokemon, which is how we store the asset config of the last transaction. So we know the current standing of this Pokemon. And we use dynamic bytes, which we import from arc4. And dynamic bytes just says, it's just a way to say this is going to be a long string of bytes, but I don't know how long it'll be, as opposed to a static byte array or static array, which means they should always be this length, and it'll fail if it's not that length. So going back here, user Pokemon box is going to be equal to a box ref, and the key is going to be a UID. So this over here as bytes plus the sender, their address as bytes. And then we're going to make sure it exists. So user Pokemon box value, whether or not it exists, is equal to user Pokemon box dot maybe. assert that it does not exist, we're going to create this user Pokemon box, and the length will be determined here. So the new user Pokemon info is going to be an instance of user Pokemon info. So the UID, we can create a arc4UN64 instance of the Pokemon created value. The owner is going to be an address instance of the sender. The asset ID is going to be an arc4UN64 instance of the created asset ID in Pokemon creation transaction, which we learned we can access directly through the transaction that was submitted. Created asset.id. And the Pokemon ID, we can do something similar to what we did here. And we can get the Pokemon ID from Pokemon selection, actually. So it's already an arc4UN64. So we can just pass this in. The level on creation is going to be 1. And XP on creation is going to be 0. By default, training on creation is going to be a false value in a bool instance. Training start time, we can set to 0. And the last note field, we can set this to the note field of this Pokemon creation transaction. Or now that I think about it, we don't even need to store the last note because everything we need to recreate the note field is already in this user Pokemon info. So we're actually going to remove this here. We won't need dynamic bytes, interestingly enough. And the size of this box will be new user Pokemon info.bytes.length. And then we're going to put into this box the new user Pokemon info as bytes. And once this is done, we won't need the claim box anymore, so we can delete this. And this is the one that held the random selection. And we are done here with minting the Pokemon. So now we need a way for them to claim the Pokemon. So we'll call this claim Pokemon. And I guess we'll put in the opt-in transaction. And this will be an asset transfer. So they shouldn't opt in without calling this claim Pokemon method. And we'll return none here. And we're also going to need the unique ID. And this will be an arc4UN64. So that they can get their Pokemon info here, where the key is the unique ID and the address of the sender. So the user Pokemon box going to be equal to a box ref, where the key is the UID as bytes plus the bytes of the address of the sender. And user Pokemon box value, whether or not it exists, equal to user Pokemon box dot maybe. We assert that it exists, and then the user's Pokemon info is equal to a user Pokemon info instance from bytes of the user Pokemon box value. And then we can, if we'd like, we can assert that the user Pokemon info owner is equal to an address instance of the transaction sender. And we can also assert that the opt-in transaction ask4asset.id is equal to the user's Pokemon info.asset ID. But we technically don't have to, because if they're not the owner of this Pokemon, then they won't even be able to get the reference correctly, because the reference is made using the address of the sender. And then also, this will fail if the opt-in transaction is not for the asset ID that they're allocated in this Pokemon box. So there's really no point to make these assertions. If you'd like, you can add them, but there's no way getting around that for the most part. So now that we have the information from the user Pokemon box, we can transfer them their Pokemon. And we can state here that the receiver is going to be the sender of this application call. The asset we're sending, we're going to get from user's Pokemon box, or excuse me, user's Pokemon info.asset ID. The fee is global.minimum transaction fee. And then we have an asset amount, which will be 1. And we can also make them pay for the transaction fee. But just for simplicity, we're not going to add that in. And similarly here, we should technically be passing in another payment transaction so that the user can pay for the box fee as well as the creation fee for holding the asset, the MBR, as well as the transaction fee. But just to speed this up a little bit, we're not going to add this. But you should make these calculations. And in one of our previous videos, we go over how to calculate the cost for the box. But in this video, we're just going to fund the contract because I feel like this is getting to be too much for you guys. And I want you to get into the more essential details here. And we're going to submit this transaction. And we'll start returning some things here. So where's our last return statement? So here, for determine user Pokemon, we can return a arc4 string. And it can be users Pokemon selected, or user Pokemon number selected, and we'll make this a tuple, so we don't have to use I to A. And this will be an arc4 UN64, the Pokemon selection. Mint user Pokemon, we can just return similarly a arc4 string. And I believe this will be a UN64 for the asset ID. So we'll return here in mint user Pokemon, arc4 string, user Pokemon generated, asset ID, and over here we'll pass in Pokemon creation transaction dot created asset dot ID. And for claim Pokemon, we'll just return regular string. You can use regular strings for any return statement, really, if you're inputting your own string. It doesn't really matter. It's only when you're trying to convert values you already have that you would want to use arc4 string or string. So I'll just return a string here to show you either way works. And the string will be user received their Pokemon. And now we can get started with trying this out, and then we'll write the training code. And the training code will be where we have the user stake their Pokemon, and depending on the amount of time staked, their experience will go up. If their experience hits a certain threshold, we'll also level up the Pokemon. So the first thing we want to do is confirm that this works and there are no errors. So let's save or file save all, and AlgoKit compile pi and arc69 NFT modifier.py. And we might have 1 or 2 errors. We'll go back and fix them. And we do. So we have errors on line 29. So too few arguments for local state. This is actually something I was experimenting with off camera or off recording. So just ignore this. And next up we have unsupported operand types, UN64, and an arc4 UN64. This is line 84. So over here. So we're trying to add arc4 UN64s with UN64s. So what we can do here is just get the native format of these arc4 UN64s. And we should be good there. And line 98. String and arc4 UN64. So we weren't supposed to add these together. These should be separate since they're tuples. Line 183, lastly, something to do with the asset ID. And this is actually line 182. We have to use asset ID dot native because arc4 UN64s are not supported as transfer assets. You need to use a UN64, a literal, or an asset class. So let's recompile. And perfect. And we can get started with register new Pokemon data. And we can even just alter our mint Pokemon. So we'll name this _1_register 3 Pokemon .py. And we're going to keep most of this the same. I think the only thing we have to do is just change the name of the method. Yeah. So instead of mint arc69, we're just going to place in here register new Pokemon data. And I'm going to check one more thing. I believe we're adding boxes. So the box size is 8 bytes. And the box name is 8 bytes. So we would need 16 bytes times 400. So 6400 microalgo plus 2500 per box creation. And we'll just round it up to 9,000. And back in our register 3 Pokemon, we will just add 9,000 to each of these MBR payments. So the MBR payment was originally just for the transaction fee. Or actually, we don't even need to pay this here because we're not minting an asset anymore in the register new Pokemon data. So we just need to pay the box fee, and we can send exactly 8,900 microalgo each time. So Control D here, we'll change both of these. Let's give it a spin. We should probably launch the contract and take notes that we adjusted our global states. So we have 1 bytes and 1 UN64 for global state now. So in our launch contract, we're going to adjust our num byte slices for global schema to 1 and keep num UINTs at 1. And launch the new contract. And let's make sure that our address still has funds in it. Same address here. And bring this up so we can see the app ID created. Replace the app ID here in our .env. And let's try registering 3 Pokemon. And we're going to get an error because we need box references. Payment transaction is also the new name for this argument here. So going back, we're going to first adjust this variable name to payment transaction. And we're going to need to make some box references. Unspecified argument payment transaction. What's going on here? Let me take a look here. In our register, new Pokemon data, name, type, description, and payment transaction. I need to do this for each compose call. Oh. Ignore me, just tripping over my feet here. And let's get these box references set up. So the box reference is going to just be the counter. So we can do this in 2 ways. We can get the current counter and then just increment that by 1 for each box reference that we need. So we're using 3 Pokemon. So we're going to need a box that has the number 1 as bytes, the number 2 as bytes, and the number 3 as bytes. So since this is going to be a brand new contract for the most part each time, we can just directly get these. So box ref 1, and let's put this right here, boxref2 and boxref3. We can just state here 1.2 bytes, 8 in big endian format. And just change this to 2 and 3. And then create transaction parameters here. And we're going to have boxes, which we know is a list of lists, where the app ID is the 0th index, and the actual box name as bytes is the 2nd index, or 1st index. And we're going to copy this. For each one. Don't forget to add a comma. And this will be boxref2 for Pokemon number 2. And boxref3. Let's move this over a bit. And now we should see that we have the proper box reference and accounts. So this is the application account. The balance of 108,900 is less than 142,100. So I'm pretty sure we calculated the box cost correctly, but it doesn't take into account the global states, I believe. So this is 8 bytes for the name. Okay. So the new Pokemon info is going to be the value we put in. So the value is not 8 bytes. And what we can do here is get the name, type, description, and hash, and calculate how many bytes that is. So we can just get the length of each of these, and sum them up, multiply them by 400, and that should be fine. So over here, we'll calculate this. So box cost 1, box cost 2, box cost 3. And this is going to be 2,500 plus for box creation. 2,500 plus the length of these 4 variables. And we can do this by simply stating 400 times the length of Pokemon name, 1, plus the length of Pokemon type, 1, plus the length of Pokemon description, 1, plus the length of Pokemon IPFS hash, 1. And we can copy this and paste it and highlight over the 1 for the box cost 2 and hit Control D. Change this to 2 and Control D for the third box cost 3. Change this to 3. And we should be good here. And then in the MBR fee payments, we will now input this box cost instead. In the amount fields. And let's see how that works out for us. We put in commas here accidentally. Perfect. And we're still below the balance. We are not including the key size. So we're going to add in here +8 because the key is going to be a uint64. And make sure that these are within the tuple, so our arithmetic is correct. And we're still below. And the arc4 standard uses the prefix yes. So better yet, we can state here Pokemon info coder is equal to ABI type dot from string, and in here we'll state string, 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 and we might as well add the uint64 here. Then we can use this info coder to encode a tuple with these values. So Pokemon name, Pokemon type, Pokemon description, and Pokemon IPFS hash. Lastly, we'll just use the number 0 because any uint64 number counts. And the length of box or total bytes is equal to the length of Pokemon info coder dot encode these values. And instead of doing this here, we can pass in total bytes. And then box cost 1, 2, and 3, still good. But we technically will have to do this for each one, since some strings are longer than others. So let's control D here. 2, 3, and total bytes 1, total bytes 2, total bytes 3. Okay. And I will bang my head on the desk if this does not work. And it looks like it's working. And we have Pokemon registered to contract. We should have added a little space there. And we can take these transaction IDs to AlgoKit. And where is the group? Okay. So there's no asset creation just yet. This is just registering the Pokemon. We can check our boxes. And app boxes will be algot-client.application boxes and pass in our application ID. as an integer. And we should see 3 boxes here. So these are the names. And if we keynotate into boxes, core box and app boxes, box value is equal to I've got a client dot application box by name, and we'll need base64 decode. So from base64, import base64 decode. And we will place in the app ID followed by the box name as bytes. And the box name we access through name key. And we need to decode this. And print the box value. And we can index into the value. Perfect. And then we can use this coder that we just created. And it's actually going to be just 4 strings from AlgoSDK.ABI, import ABI type. And we can use this coder without the uint64 at the end. That was just used to calculate the total byte size. But the value is actually just 4 strings, as you can see here. And we can state here decoded box value is equal to Pokemon info coder dot decode base64 decode the box value. And we can print the decoded box value. And hopefully see our Pokemon info, which we do. So Bulbasaur, Grass, Grass Pokemon, IPFS hash. So these are the box values, as indicated by the struct. So now that we have 3 Pokemon registered, we can now test a user getting one of these randomly using determine user Pokemon. So we'll create a new file, and we can even copy this. So hover over the file, click it, hit Control-C, then Control-V, and we'll rename this get or determine user Pokemon .py. And we won't need any of this. We won't need the coder or the length of bytes. We won't need the box cost. We might need a payment transaction. I mentioned that I wouldn't go over the math, but this one's pretty easy. So it's just going to be 16 bytes long. So I'll return this here. Assert payment transaction dot amount is equal to 16 bytes times 400, so 6400, because the key, the key is 32 bytes for the sender address. The value is 8 bytes. So it's going to be 40 times 400 plus 2500. So this needs to be 18,500. Can't use commas here. And what we'll do here is adjust this payment amount to 18,500. We won't need 3 of these. And we won't need box references, except for one, which is going to be our address decoded. So from algo SDK dot accounts or encoding, import decode address. And we won't need all these compose calls. So boxref1 is going to be decode the address of our accounts, which is address right here. And we won't need any of these arguments or a box reference. And the name of the method is determined user Pokemon. Oh, I lied. We do need a box ref. And we should be good here. So let's give this a spin. And we had an overflow error. And what that means is that one of these numbers exceeded the max value of a uint64. And that's very possible when we add 2 values. So if we add these together, there's a chance that we go above a uint64, and we can't subtract them either because we'll get a negative number, potentially. So what we can do here is it's more likely that if we do a modulo, we'll be okay. And let's try compiling this. And we'll launch the contract. Input the new app ID. And the modulo we just adjusted was in determine user Pokemon. So we change this from a plus to a modulo, which is a percent sign. We have our new app ID. Let's register 3 Pokemon again. You don't have to fund your account again. I just want to be sure I don't run out of algo. And let's give this another shot here. And looks like it's executing, so we're good. And user's Pokemon was selected, and they're going to get Pokemon number 1, which was Bulbasaur. And now we can try the third function, the last one, which is mints user Pokemon, before we start the training methods and claiming them. Actually, so we have mints and then claim. So we have 2 more. So for mints, we don't need this allow actions. So we're going to remove that. Let's copy and paste the determine user Pokemon. And I'm going to just push this stuff down a bit and focus on the payment so we can do some calculations. So how do we know the cost? We're going to rename this 3_mint user Pokemon. And we're going to get the current Pokemon that they have selected. And this is going to be in the user claim box. So we're going to look for a box, and I'll comment all this out in the meantime. So use 3 apostrophes here. So we're going to get the user Pokemon selected, which is going to be algoClient.applicationBoxByName, pass in the app ID, and our address decoded is the name of the box. So address decoded, or we can even say Pokemon selected box name is equal to decode address and our address, and pass that in here. And print user Pokemon selected. And you'll see here that we get a box back with this value that we need to access. So we're going to go into the value and base64 decode this user Pokemon selected. And we need to import that from base64, import base64 decode. You can either use ints from bytes, or you can use a uint64 coder. I'll just show you both examples. So uint64 coder is equal to ABI type.from string, apostrophe, a tuple with just one uint64 within it. And we can use here b64 decoded value and integer or Pokemon selected is equal to Pokemon selected box, or excuse me, uint64 coder dots decode. And alternatively, you can use Pokemon selected is equal to int.from bytes, 8 bytes long, big endian format. And you'll see that either way, we get the same value. Oh, you don't put 8 in here. You put the B64 decoded value. Perfect. And if we're using the coder, we have to access the first index, or the 0th index, first position. So you could use either method. So you can use the uint64 coder, or you can use int from bytes. And now that we have the Pokemon selected number, we know which box to use. So boxref is equal to, we won't even need the number. We can actually just pass in the B64 decoded value. But if you wanted to know which Pokemon was selected, this is how you would do it. And then we also have to pass in the boxref for our address key. And we already have this here. The decoded address, we'll create a new variable, decoded address is equal to decode address, and then we'll place this in here. And we'll call this boxref2 is equal to the decoded address. And the MBR payment, we're going to be creating a box for new user Pokemon info. And this is going to be a fixed length. And we can do what we did here and determine user Pokemon. Nope, register 3 Pokemon. So Pokemon info coder and the user Pokemon info coder. And we can copy and paste this here to reference it. So it's going to be a UN64, an address, a UN64, 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 a fourth UN64, a bool, and then a UN64. And then the key is going to be the UID, which is a UN64, and the sender, which is 32 bytes in address. So when calculating the length, we can just pass in an extra UN64 and address. And actually, we don't even need to use the coder. We can just calculate this by hand. So we have 1, 2, 3, 4, 5, 6, 7 UN64s. So 7 times 8. Then we have 2 addresses, 32 times 2. And then we have a Boolean, which is just going to be 1. So total bytes is equal to 7 times 8 plus 32 times 2 plus 1. And the box cost is equal to total bytes times 400 plus, and let's enclose these so our math is done correctly, plus 2500. And now we know how much they need to pay. And that's going to be box cost. And we'll bring these box references down here. And we can bring up our application call. And this is going to be the method called minceUserPokemon. And the payment transaction, we originally did not want to pass in, but now that we did the math, we can pass that in. And this is actually going to be fixed, so I'll tell you the value now. And we have an error somewhere here. Just comment this out for a second. So you can use time sleep, import time sleep if you just want to see a quick print statement before executing anything. I'm just going to get the box cost here. So 50,900 and stop this code. So we're going to assert here payment transaction dot amount is equal to this amount, and assert that the payment transaction dot receiver is the current application address. And we can even, we'll leave the math here for calculating. And then we're going to put in our 2 box references to our list of lists. Call this box ref 1 and box ref 2. And we need to compile our changes. Oh. And launch. replace the app ID, register 3 Pokemon, determine the user Pokemon, and fingers crossed, so they got Pokemon number 2. Let's get to invalid box reference number 2. And box ref 1 is user Pokemon selected. Let's print user Pokemon selected. See what's going on here. And we are grabbing the base 64 version. We need this B64 decoded value. So replace user Pokemon selected with B64 decoded value. And we'll get the bytes format of that. And details, app global get X. The global state does not exist. We need to set it to 0 so that it exists. And let me just check something here. We need to increment the Pokemon created. So down here, we're going to add a comma. Fee is equal to global.minimum transaction fee under the mint user Pokemon function. And from scratch, launch. App ID replacement. Register 3 Pokemon. Determine the user Pokemon. Mint user Pokemon. And slowly but surely, we will hopefully not have an error. Oh my goodness. When we mint the Pokemon is actually the UID plus transaction sender.bytes. The UID as string, so we'll go here. Application info, pass in the app ID. I'm going to add time sleep again so we can work with this. And let's print the application info. We're going to look for the key in global state, which is under params. Okay, and we need to figure out which key represents the Pokemon created value, which we use as the UID. So what we can do here, since this kind of changes sometimes, I believe this is not a fixed result of what the keys look like. So this might be in the first index next time. What we're going to do is for key, we'll change this variable to global states. For key in global states, prints B64 decode key, and we need the key value. Okay, so Pokemon created. Let's refresh, see if it changes. Even if it doesn't, it might be safer to verify which one we're indexing. So if B64 decoded key is equal to bytes Pokemon created, the current UID, unique identifier, is going to be key And the value we can get directly. Let's just print the key for now. Let's see what that looks like. Yeah, so we need this here, uint. So current UID is equal to key value uint. And this is going to give us an integer back. We need the string version of this. And we also need it encoded. So we're going to encode at the end. And then for our box reference, it will be the current UID as bytes. So the string of 0 encoded plus the decoded address, which we indicate here. And we're actually also going to need this box here. So we have one with our address. We have one with the UID and address. And then we have one for user's claim box, which is just the address alone. So the third one is just the decoded address. So we're going to add a third box reference. We are incrementing by 1 for the first Pokemon, but by default, Pokemon unit counter is already at 1. So we need to start this off at 0. We're going to add at the beginning. Because we use the Pokemon unit counter as the box ref here. And launch. Replace the app ID. Register 3 Pokemon. Determine user's Pokemon. They got Pokemon number 3. And now we mint user Pokemon. Perfect. We need to remove this time and box cost. Looks like it's going through, finally. And we have the user Pokemon generated. This is the asset ID. And there it is. We can take this asset ID and see that they got the Squirtle. Let's look at Para. Yep, there it is. And our metadata is nice and formatted. We have our Pokemon number. And when we claim here, so you see the UID is 0. And it would be interesting to add address in here, but we'll leave it as is. And next we're going to work on claiming that Pokemon. And I'm going to rename this claim user Pokemon.py. And we're not going to need a lot of the stuff in here. So we're not going to need 3 box references. It's just going to be 1, the UID and our address. And we're not going to need a payment transaction, although we should probably send 1 algo. or not 1 algo, but 1,000 microalgo for the fee here for the asset transfer. We'll even make it 2,000. So we'll just manually add this to the compiler, the group compiler, transaction compiler. But typically you would include this as an argument as well. And this is going to be called claim Pokemon, the ABI method. So we change this here. The argument will no longer be payment transaction, it'll be opt-in transaction. So change the variable name, and then we're going to create a variable called wrapped opt-in transaction. I'm just going to add this wrapped payment transaction into the group, but not include it as an argument. We don't need these global states and keys. We don't need a coder. The asset ID and the UID we're going to pass in manually into this code. So we don't need this. We don't need to print this. I added this earlier. And we're good. So the current UID is 0 because we self.pokemon created. I just saw it actually. So this starts off at 0, and then we only increment it after the Pokemon's minted and the box is already created. So UID is going to be 0 as a string, actually. So this is going to be bytes 0. And the decoded address, this is fine. And then we also have the asset ID, which I saved here. User is Pokemon. And this is going to be needed as a foreign assets reference, which is also a list. We'll just pass that in, user's Pokemon. And the wrapped opt-in transaction we can create now. Let me make sure I have, yeah, I need asset transfer transaction. And you can also use asset opt-in if you'd like. The only difference is one has the sender and receiver. For an asset transfer transaction, if you want it to be an opt-in, you just set yourself as the receiver as well as the sender. I'm pretty sure amount can be 0, and you'll be opting in to the asset this way. And we can even try this here instead of the asset opt-in. So right here, after the payment transaction, user opt-in transaction is equal to an asset transfer transaction, where the sender is our address, and the receiver is also our address. The params we pass in here. Amounts you can set to 0, and the index, we're going to need our user's Pokemon variable above this here. And then we're going to wrap user opt-in with our signer. And this will be passed in as an argument. And we should be good here. Let's give this a try, see what happens. Unspecified argument, we forgot the UID. So UID occurs, well, the order doesn't really matter, but we can just pass it in after opt-in. And it wants this as a uint64. So over here, we'll say UID is equal to 0. And we need a comma here. Unused arguments specified, owner address. So I was experimenting with something. It turns out it's not possible. I was trying to add in an owner address, but you can't pass in an address as a string at the moment. Well, you can, but it's quite a heavy opcode usage, so I'm not going to do that. I'm just going to recompile. And this means we're going to have a new asset ID. The UID will be the same because we always start from 0. And I'm not sure if I saved, so I'm going to also need to remove this here. And we don't need to pass in owner address. Cool. And let's launch. Replace the app ID in our .env. And register these 3 Pokemon. Just fund my account just in case. Determine user Pokemon. Mint user Pokemon. So he got Pokemon number 3. And we're going to get our asset ID here. And I have another print statement I'd like to remove. So we have the asset ID. So in our claim user Pokemon, we're just going to replace the user's Pokemon here. And owner address, same thing. This I meant to remove. Invalid box reference. So I'm going to change something here. I'm going to pass in Pokemon created as an arc4UN64. So we're changing the global state for Pokemon created to arc4UN64. And then down here in the mints user Pokemon, we're going to use the UID directly. So self.PokemonCreated.value.bytes. This way we don't have this weird 0 byte as the in the box name for the UID. So we change the global state to arc4UN64 for the Pokemon created, and then we change the key to self.PokemonCreated.value.bytes plus transaction sender.bytes. And we should be good here. Let's compile. And in our claim, we can change this to 0.2 bytes, 8 big. And we can't use plus or equal 1 anymore. So we're going to state that the self.PokemonCreated.value is equal to our arc4UN64 instance of self.PokemonCreated.value.native plus 1. And we also need to adjust this somewhere else here. Nope, it's just there. And line 121, we need to pass this in as native. And line 149, this doesn't need to be wrapped with an arc40 since it is already one. So in user Pokemon info, we also removed the arc40 wrapper here. And make sure you also adjusted in UID as string and mints user Pokemon. We added dots native here. And now that we've compiled, I'm going to launch the contract. And we have to adjust our global schema to 2 bytes and 0 ints. We did not change the app ID. So we're going to do that here and retry. So register, determine user Pokemon, mints user Pokemon. We got Pokemon number 1. And we have an invalid box reference here. This was in mints user Pokemon. And the current UID is just going to be the key value integer. And current UID. So we do need this as bytes. So dot 2 bytes, 8 big. And we now have our new asset ID. It's going to go up here. And finally, so we're getting our Pokemon. User received their Pokemon. And we can see here that we paid for the transaction fee. It sent us the Pokemon, or actually we opted into the Pokemon. We made the app call to have the app send us the Pokemon. And if we look at our Pokemon, testnet, we can even get the app ID, asset ID here. Yep, perfect. So now we're going to train this Pokemon. So we're going to send it to training and get it back after a period of time and check out its new level and experience. So training the Pokemon is going to be pretty straightforward. Go down to the bottom here of our contract. And we're going to create a new ABI method and call it train Pokemon. Pass in self a stake Pokemon transaction, which is just going to be an asset transfer transaction. And the UID again. This is going to be an arc40 We'll return none for now. So the first thing we need to do is confirm that the amount that they're sending is equal to 1. And we need to assert that the receiver of this asset and this transaction is the current application address. And the Pokemon we plan to train, Pokemon to train, is the asset ID in the asset transfer. And the user's Pokemon info, as we got before, is a box reference where we pass in the key as the UID as bytes. and our address as bytes. And we're going to confirm that it exists. So value exists, or yeah, value exists is fine. Users Pokemon info dot maybe. And we're going to assert that it exists. And the current Pokemon info is an instance of user Pokemon info from the bytes of the value of that box. And now we're going to assert that the Pokemon to train, or the asset ID of the Pokemon that they're sending, matches the current Pokemon info dot asset ID. So the asset ID that we saved for this user's Pokemon info. And now we can set the current Pokemon info training start time to an arc4uint64 instance of the current time. So we're going to keep it simple. Just every second that it's staked, we're going to increment XP and potentially level. And you'll see that in the next function. And we're also going to set current Pokemon info.training to a Boolean class of true. And now we're going to input this new information. So current Pokemon info.bytes. So what we do is we confirm everything about this asset transfer for the Pokemon that they're going to stake matches. And now we can compile this. I'll go kick compile pi, and we can even return a string here, Pokemon staked. And type annotation up here needs to be corrected. And now we can compile, so arc69 NFT modifier.py. Oh, we should probably save those changes. Always make sure to save before you compile. And we're good. Now we can write the remove Pokemon from training before we experiment with this. So we're going to create a new function called remove Pokemon from training. Pass in self and the Pokemon requested ID. Return none. So the user's Pokemon info box, and this should be UID, so you have a better understanding of what I mean by ID. So user's Pokemon info box is equal to a box ref, where we pass in the Pokemon requested UID, bytes, and the transaction sender bytes. And value exists is equal to user's Pokemon info box dot maybe. Assert that it exists. And then we're going to get the Pokemon info. So users Pokemon info. We'll call this current user's Pokemon info, actually. Is an instance of user's Pokemon info from bytes of the value of this box. And then what we want to do is also get the general Pokemon information. So all the information about this Pokemon by default, like the Pokemon's name, the Pokemon's ID, the description, because what we're going to do is rebuild the initial metadata about the Pokemon using the information in the user's box about their current Pokemon and the initial information about the Pokemon. when we initially register them to the contract. And that is in this struct up here, available Pokemon. So we're going to state general Pokemon info is equal to a box ref, or general Pokemon info box is equal to a box ref, where the key is current user's Pokemon info dots Pokemon ID dots bytes. And then we can start rebuilding some of these variables about the metadata. So the first thing we can work with is the unit name int as string. And we should probably get the general Pokemon info first. And this is going to be an available Pokemon instance from bytes. And what I'm going to do here is I'm going to change this to users Pokemon info value. And then this one is going to be general Pokemon info value. This way we don't have these values overriding each other if we reuse them. And we need to change this here. And now the general Pokemon info we can get from this value from the box. And we're not going to need the general Pokemon info for quite a bit, but I just want to get these box references out of the way here. But we can start preparing some of the information about the metadata. So from the users Pokemon, or here, current users Pokemon info, we can get the unit name as a string. And this is going to be string.fromBytes self.I_to_a. So we're converting that number into a string. And this is going to be current user's Pokemon info dots and the Pokemon ID. And we also need this to be native. And now we're going to need to get the current level and experience for this Pokemon that we're going to include in the metadata. So the initial training time, and we're doing 1 XP per second, so initial training time is going to be current user's Pokemon info dot training start time, and the current time is going to be global.latest timestamp. The time difference is going to be current time minus initial training time. And we're going to need to get the .native version of initial training time. The current level is going to be current users Pokemon info .level .native. And the current experience is going to be current users Pokemon info .experience or XP .native. And this is where we're going to do the math to determine whether or not we're going to increment the level. And the way that we calculate the new level and experience, I'm going to walk you through it now. So we start off with base experience. And this is going to be a UN64 200 because we can't just define it on its own this way. And it's easier to perform arithmetic with the UN64. You can't really do it with an ARC4 UN64 without making it native. But anyways, so the base experience is 200, and per level, you need 200 times the current level. So if you're level 1, you need 200 times 1 experience to get to level 2. If you're level 2, you need 200 times 2 experience to get to level 3, so on and so forth. So we define cumulative experience is equal to the current level times the base experience. And the total experience, so our current experience after staking, is going to be the current experience plus the time difference. And since we can't have negatives in AVM, a number can never go under 0, and it can also never exceed a UN64. What we have to do is calculate this in a way where if they're not going to level up, we don't try to subtract the cumulative experience from total experience. And this sounds a little bit confusing, but just copy down this code. So if total experience is greater than or equal to the cumulative experience needed, then we calculate the levels gained, which is total experience plus base experience minus cumulative experience needed. And then we divide this using floor division with base experience. And then their new level is going to be the current level plus levels gained. And their new experience is going to be total experience minus new level minus 1 times base experience. And this is a way to get around getting negatives and not being able to divide with fractions. And then if total experience would not result in leveling up, so if else, new level is going to stay the same as the current level, and new experience is going to be the total experience. And now we can start with our asset config and recompiling the note field. So the sender is our current address. The manager is our current address of the application. The configuration asset, or the config asset, is going to be current users Pokemon info.assetid.native, because we can't use Arc4 UN64s here. The note field, we're going to try to format it the same way we did previously. So I'm going to go over to Mint Pokemon and just copy this so we don't have to type it all out. And make sure you don't forget the fee at the end. And submitting. So instead of available Pokemon info, we're going to use general Pokemon info, which we created right here. And this will get the type of this Pokemon. Same thing with description. And for unit name int as a string, we have that up here. And for the UID, we actually need to calculate this right here. So the UID as string is string dot from bytes self dot I to A. The current users Pokemon info dot UID dot native. And now we also need to change the level and experience, and we need it as a string, so we can do the same thing. I'll put it before the UID, so it comes before the UID. The new level string is string.fromBytes self.I to A, new level. And same thing for the new experience string. And now we just replace this here. So we're going to need to add here. So we can just copy this and just overwrite up to here and place in the new level string. And same idea here. And place in the new experience string. And one more thing, at the end of remove Pokemon from training, we need to update the user's Pokemon box information. So we're going to take this box here, user's Pokemon info box, and at the end of our function, after we transfer them back their Pokemon, we're going to state here user's Pokemon info box.puts, and we're going to just adjust the level, experience, and training boolean. So we're going to grab the current user's Pokemon info, and down here, current user's Pokemon info dot level is equal to new level, and new level needs to be in arc4 UN64. And we're going to do the same thing for experience. So exp, new experience. And for training, current user's Pokemon info dot training is equal to bool false. And we don't need to reset the training start time because that resets itself in the train Pokemon function. So it's always gonna, the only way for Boolean to be true for training is if they call this function and we give a new time for when they stake. And then we're gonna put in the new Pokemon info bytes. And this is technically new Pokemon info. I believe you could copy, so new Pokemon, new users Pokemon info is equal to current users Pokemon info dot copy. And then we can work with new users Pokemon info. And that way it feels a little bit more syntactically correct. That word's a bit tough for me. But yeah, and let's compile this and make sure it works. I'll go compile pi, arc69 NFT modifier.py. And we might have an error somewhere, let's see. Nope, we're perfect. And that's pretty much it. Let's compile. Arc69 NFT modifier.py. Make sure you save, file save all. And we're missing a return statement. So we're going to return a string. I have this here set to string now. Pokemon removed from stake. Copy our claim user Pokemon and start working on staking the Pokemon, stake user Pokemon. And for our stake or train Pokemon method, we only need to pass in an asset transfer and the UID. So we still need an asset transfer, but this time it's going to be a transfer of 1. And we're going to get a new user Pokemon. Payment transaction we'll keep this way. 2,000 is perfect for 2 transaction fees. We'll even change it to 3,000 just in case. And everything else changes the variable name. So stake Pokemon transaction from opt-in transaction. And this is technically not an opt-in anymore. This is a stake Pokemon transaction, since we're sending one of the asset. And the receiver needs to be the app address, which we can get from the application client. Wrapped stake transaction. And UID is still going to be 0. And we can get started. So let's launch the contract. Let me just save all. Launch the contract. Replace the app ID and our .env. Register 3 Pokemon. Determine the user Pokemon. Mint user Pokemon. We got Pokemon number 3. And for claiming the Pokemon, don't forget to change the asset ID. And this would be in your return statement. And the current UID will always be 0 for the first Pokemon. And change the asset ID for stake as well. So right here, give this a try. And while it's staked, so let's copy our stake user Pokemon. And we'll name this unstake user Pokemon. And we're going to need 2 boxes. So one will be the UID and sender, and the other will be the Pokemon ID. And the Pokemon ID we're going to pass in manually, but you could also get this from the box if you'd like. So you could query the chain for box information that has the user's UID and the sender. And then this box has the Pokemon ID as well. But we know that it's Pokemon number 3. From up here, where is it? My terminal's messed up, but I did see it was number 3. So we'll just input that there. So in unstake, we're going to send the payments for 3,000. Let me just check something here. We didn't really need to send a payment for trained Pokemon. So in the stake user Pokemon, you can remove this MBR payment. But going back to unstake, so user's Pokemon is good. Current UID. So all we need to do is pass in a second box ref. And this is just going to be the Pokemon's ID, 2 bytes. So right now there's Pokemon 1, 2, or 3. And this is going to be 8 bytes, UN64, big. And we're going to pass this in as another list in our box references. So app ID and box ref 2. And we won't need a stake Pokemon transaction. We'll just need the UID. We need to change this method name for unstake. So remove Pokemon from training. And this is Pokemon requested UID. So we're going to change that here. And take a look at this Pokemon. So the experience is already updated here. So this transaction went through. And we can stake it again. And we also need to remember to actually send the asset back. So after this, we're going to have an asset transfer. And we don't need to define the sender actually. The receiver is going to be the transaction.sender. The asset amount is going to be 1. The ax for asset is going to be the current user's Pokemon info.assetid.native. And then the fee is going to be the global.minimum transaction fee. And then we make sure to submit this afterwards. And compile. And then we can have an error here. Asset receiver, not receiver. And we can launch our new contract. Register after inputting the new app ID. Register 3 Pokemon. Now let's just fund this account. Make sure it's good. And now we can determine the user's Pokemon and then mint it once that's done. And they got Pokemon number 3. And we have the new asset ID for the Pokemon. Change that here in user's Pokemon and claim user Pokemon. Also change it in stake user Pokemon, as well as unstake user Pokemon. And we also need to change the box ref to 3, since it's Pokemon number 3. And we'll wait a few seconds. I think it's been about maybe 10 seconds already. And we can see the changes in the Pokemon experience. So we'll go take a look now. And you'll see that the experience is 0, levels 1. And when we unstake, so Pokemon removed from stake. Oh, opened my Discord by accident. And when we refresh this page, we can see that the experience incremented. And we can also stake it back again and make sure that the level increments. So I'm going to step away for a bit and come back. All right. So let's unstake our Pokemon and take another look. And we left him at level 1 with 39 experience. Refresh, and he's now level 3 with 120 experience. And that is the ARC69 modifier. You can adjust this to your liking. Doesn't have to be Pokemon. It could be something else if you have a collection already. You can add this to some sort of game. If you have some sort of game you want to play, you can adjust some of these values. It doesn't have to be staking. You can add battles. That's something I wanted to add, but this video is already a bit long. But yeah, this is also the last video for the AlgoLearn tutorial series. So I hope you guys enjoyed it. I hope you learned something. I hope you found this to be a passion if you followed through all of it and you built something cool. The AlgoLearn series, when proposed, It was mentioned that this wouldn't include any UI tutorials, so like React, Svelte, Next.js. We wouldn't be building front ends, but I would love an opportunity to build some front ends for some of these things. I'm not a great front end developer. I've made some, MVPs and wireframes that worked, but it would be nice to refine that and get a chance to have you guys bring these to life on some sort of UI, maybe even start a project or something. But yeah, I appreciate everyone's time. All this code is open sourced for the AlgoLearn website. We just about finished up with the UI, so try to make it as organized as possible. And yeah, thank you. Thank you for giving me this opportunity to teach you.